Let's look at this figure again, but this time let's talk about a one-tail test. Rather than saying that the true population mean is equal to 6,000 or it is not equal to 6,000, we're going to say that the true population mean is less than or equal to 6,000, or the alternative will be that it is greater than 6,000. As we saw in Chapter 7, this gives us the opportunity, if we wish, to calculate a value of beta, that is type 2 error, for our hypothesis. But rather than concentrate on that at this point, let's simply concentrate on the area in which we would reject the null hypothesis. Now, if we say that the alternative is that the mean is greater than 6,000, and we're calculating our t-test as the sample mean minus our hypothesized mean of 6,000 divided by the standard error, any value that would lead us to reject H0 must be a positive value. And this means that the red line here is irrelevant, so I'm going to get rid of it. Now the region of rejection of our null hypothesis is only to the right of the red line shown at 2. However, the red line as now positioned only excludes 2.5% of this total blue distribution. So in order to correct for that problem, we need to get the critical t-value for an upper limit only of 5%. In order to do that, we have to change the 0.05 to 0.1. And this gives us a critical t-value of 1.66, which means that we must move the red line down to 1.6, or 1.66, which is approximately here. Now, any value we get in our t-test that's greater than this red line that is in the distribution to the right of the red line will lead us to reject H0. Well, let's put our blue line back again where it would be approximately here, and we can see that we would not reject H0 in favor of the alternative. We would conclude that the true population mean is equal to or less than $6,000. What if we had said that the true population mean is greater than or equal to $6,000, and the alternative is that the population mean is less than $6,000? In that case, our red line would have been down at 1.66 below the mean. One of the things that we should recognize in a situation where we have a less than hypothesis of this type and the sample mean is greater than the hypothesized population value, there's no need even to carry out a t-test. Why is there no need? If we have a sample value greater than the hypothesized mean value, and the alternative hypothesis says that the mean value is less than the hypothesized mean, there's no way that we would ever reject the null hypothesis. In other words, if the alternative hypothesis is on the opposite side of the mean from the sample value, the t-test is unnecessary.